Hello. I'd like to continue talking about the internet layer. And we talked about the IPv4 addresses. Now I want to talk about IPv6. The internet started using IPv6 addresses in 1999. But the IPv4 addresses will never die. It's been over 21 years, and yet even some of the advanced countries haven't converted more than half their sites to IPv6. So it's taking quite a while. There was an IPv5 I read on the internet, but it was it fizzled out. It was not really a reasonable way to do anything. It was really sort of an add-on to IPv4. Now, each IPv6 address is 128 bits. It is written in the form 8 groups of 4 hexadecimal digits separated by colons. So each of the X you see in that description there is a hexadecimal digit, something between 0 and F. Now, you people are far enough along in CS to know that each hexadecimal digit can be represented as 4 bits in binary. So we have 8 units here, and each is 4 bits. That means we have 32 hex numbers, and 4 times 32 gives us the 128 bits. I put an example here, and this example shows that we can abbreviate. For example, there's a leading 0 here. There's no reason to put that in. So instead of writing 0896, we'll write 896. And there's 2 leading zeros here, so we'll just write 35. We can't drop the 0 at the end here, because that would be ambiguous. We wouldn't know whether it was 0FF3 or FF30. So it's only leading zeros we can drop. When there's a group of 4 bits together that are 0, we can omit them and show that we omitted them by doubling the colon. So even if there were 3 or 4 of these, we would still only have colon. We wouldn't have more than 2 colons. And we can tell how many have been omitted by counting the ones that are there and subtracting from 8. They use the CIDR notation that we use for the IPv4s. For example, if I were to write this, that would be all the addresses that begin with the prefix FEOO, blah, 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 blah. There's 64 bits there. Strangely, when a user buys an IPv6 address, he's given an address, but it's said to have a prefix of 64 bits, even though he only gets one group of the last 64 possibilities in the address in that group. The others would probably be assigned by the ISPs working with 2 others in the same group. The reason they use this prefix is to make the router tables more handleable, smaller. Now, user addresses are called aggregate global, and they always begin with the 2xxx or 3xxx, and I can show you that mine does, because if you look at any of the captures I put on the Sakai, you'll see that mine is 2600 something. So all these addresses begin with 2 blah 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 or 3 blah blah blah. Now, what about the others? Well, they all have meanings. If an address begins at FEC0, then that means that address is within your autonomous system. You're trying to get to somebody within your system. Well, that means it doesn't have to go outside your system. So the routers or whatever would not try to send it out to the whole internet. If the address begins FFXX, then this is not an address to one destination. It's an address to a group of destinations. This is called a multicast. Now, the group can have all different kinds of meanings. It can be everybody within your AS. It could be a particular group of routers. IPv4 couldn't do this. They had just one multicast that had to go to everybody. But this one can give you different groups that you can send all at once. One of the uses of a multicast is to find out who your neighbors are. You send out a request to see who your neighboring routers are. And that way you can begin preparing the routing information you need to send things across the internet. Unlike the IPv4 addresses, IPv6 addresses can actually tell you something about the hardware that's being used. For example, it can tell you who created it, who made it. Was it Cisco? Was it somebody else? The reason for that is that the lower 64 bits are created out of something called the MAC address, the Media Access Control address. It isn't enough that we have IPv6 addresses and that we have URLs. We have to have yet another addressing system called the MAC addresses. Now, these are there because this was how Ethernet did things. And Ethernet is the main technology used in local area networks. Every network interface card is given a unique number when it's created. Each company has a certain part of that number that refers to its company, and then it puts the rest in. Now, I don't know if I didn't try looking at this, but I think I can find some. Mostly they would be in this area. I don't know for sure. I think we can see some that start with Cisco if we look. Well, I guess I didn't hit any that did that time. But I have seen some that start, well, you can see there's some broadcast ones there. Let me go down. I don't think we're going to see any. But I have seen it in some of the ones we've done where it hasn't been a numeric address. It's begun with letters like Cisco. Now, that more or less, I think, is everything I want to talk about with IPv6. The next step is to look at the routing tables in routers and how they're organized. Then the next step after that is how the routes through the internet are done. Although before I do the routing tables, I'm probably going to talk about the ICPM, I think it is, or IPCM, the control message parts that is an integral part of the IP protocol. So that'll be next. See you later.